Hi friends, in this video we are going to look at Newton's second law of motion. Newton's second law of motion is called the law of force and acceleration, but we'll just call it second law for short. Here's some vocabulary that will be really helpful for you in this video. So first, velocity, remember, is speed in a specific direction. Acceleration is a change in velocity, so anytime speed or direction changes. Mass is the amount of matter in an object, and force is a push or a pull. This is what Newton's second law actually says. The acceleration of an object depends on the mass of the object and the net force applied. You've likely experienced this in your everyday life, and you just never really realized it yet. So what it means is that the mass, the force, and the acceleration of an object are all proportional or related. The size of one depends on the size of another. Here's some examples. It's a really large mass. Think about pushing something really, really heavy. You have to apply more force to make it accelerate or move. So the more force you apply, the more it accelerates or the faster it accelerates. The smaller something is, the smaller mass it has, the less force it requires to make it accelerate or move. So the less force something has, the less it accelerates, the slower it goes. In this example here, we see the same amount of force is used on two different masses. So imagine you're pulling a wagon and you pull the wagon, no matter the size of the wagon, no matter what's in it, you pull it with the same amount of force. When the mass is really small, you accelerate really fast. So it's really easy to push that cart or to pull that cart. When the mass is really big, when you have something really heavy in the cart and you pull with the same amount of force as you did in the first one, it accelerates a lot slower because it's heavier, so you don't go as fast. The one with the larger mass will require more force to actually move the object. So if you want it to go faster, you have to apply more force to get it to go. But wait, there's more than just describing these forces. Of course there is. We can actually solve for exact amounts of force, mass, and acceleration too using this very special formula, F equals m times a. The F stands for force, and its unit, I just combined those words. Its unit is the Newton, remember that. M stands for mass, and its unit is kilograms. And A stands for acceleration, and the unit for acceleration is meters per second squared. Keep in mind that looks very similar to speed and velocity, but acceleration, the difference is that little 2 as the superscript. So I would screenshot this if I were you, because you are going to need these. You can also screenshot this. That one formula can actually break into 3 depending on what you actually need to find. If you need to find force, you use the one in the blue box. If you need to find mass, you use the one in the middle, m equals F divided by A. And if you need to find acceleration, the formula is A equals F divided by m. So we're going to practice a few just to make sure you know it. Our first practice here. What net force is required to accelerate a car at a rate of 2 meters per second squared if the car has a mass of 3,000 kilograms? First, we need to identify our equation. And if you want, go ahead and pause the video now to work out the problem yourself and then follow along as I go through it. When I look at my problem, I see that it's asking, the question is, what net force is required? So I know that my equation that I'm going to use is F equals m times A. Then I go back to my problem because I know I need to find mass and acceleration. So I'm going to use my context clues here of units because I know what the units are, where it says mass of 3,000 kilograms, so I know that's mass. Accelerates a car at a rate of 2 meters per second squared. Notice that 2, the little 2 up in the top. I know that's acceleration. So I plug in my numbers here using my formula, mass of 3,000 times an acceleration of 2, and that gives me 6,000 newtons. And I used a calculator for this, so don't be scared. You can use a calculator. Here's another one. Pause the video to practice and then press play to check your answer. All right, so first I need my equation. I'm going to look at my problem to see what it's asking, and it asks, what is the mass? So I know my equation that I need is mass, which is m equals F divided by A. So I look back at my problem because I need force and acceleration, and I see force is 14,000 newtons, and I see acceleration is 5 meters per second squared. So I plug in my numbers, mass equals 14,000 divided by 5, and I get 2,800 kilograms as my mass. Last one, pause the video, practice, and then press play to double check your answers. All right, you should be getting the hang of this now. First, you identify your equation, and you do that by looking at the problem. What is it asking? And in this one, it's asking, what is the acceleration? So I know my formula is this one, A equals F divided by M. So I look at my problem. I need force. Well, it says force is 25 newtons. I need mass, and it says it has a mass of 0.5 kilograms. So I use these numbers and plug in the formula. A equals force, 25 newtons, divided by mass, 0.5 kilograms. And using a calculator, I find that the acceleration of the softball was 50 meters per second squared. Hopefully you're getting the hang of this by now, but if not, don't worry, you can ask questions, and you should ask questions if you need help. So if you're getting it, great, move on to the next DIY. If you're not, pause and ask your teacher for help.